Okay, 3.5, inequalities in a triangle. We all recognize this right here. A is greater than B. Okay, we're going to be talking about that a lot when we talk about inequalities in a triangle. Okay, so here are some important things that you should remember. The measure of a line segment is greater than the measure of any one of its parts. So what that's saying is that AC is going to be bigger than AB, and AC is greater than BC. That makes sense, right? This is just a portion, this is just a portion, but this is the whole thing. The measure of an angle is greater than the measure of any one of its parts. Well, that makes sense. I know that this huge angle here, ABC, obviously is bigger than ABD, and ABC is bigger than DBC. So that means that angle ABC is greater than angle 1, and it's greater than angle 2. Okay, the measure of an exterior angle of a triangle, remember that would be angle 3 here in this case, is greater than the measure of either non-adjacent interior angle. Now, we know from before that the measure of angle 1 plus the measure of angle 2 has to equal the measure of angle 3. Do you remember that? Now, this is saying that the measure of angle 3 is greater than the measure of angle 1, and measure of angle 3 is greater than the measure of angle 2. So all it's saying is that this exterior angle here is bigger than both angle 1 and angle 2. Okay, if a triangle contains a right angle or an obtuse angle, then the measure of the angle is greater than the measure of either of the two remaining angles. That makes sense, right? This angle here is 90 degrees. There's no way for this guy or this guy to be 90. Same with this one. If he's bigger than 90, there's no way that this one or this one could also both be bigger than 90. So if you have a right angle or if you have an obtuse angle, those are both bigger than either of those other two angles. The addition property of inequality is important to remember. That's saying that if A is greater than B and C is greater than D, then if I add the two bigger pieces together and I add the two smaller pieces together, I'm still going to get that A plus C is greater than B plus D. You can think about it in terms of, well, 5 is greater than 2 and 3 is greater than 1. Well, if I add them up, 5 plus 3 better be greater than 2 plus 1. Well, that's 8 is greater than 3? Yep, so that's always going to be true. Okay, here we talk about some sides and angles. The longest side in a triangle is across from the largest angle. So here angle B is the largest angle, so AC is going to be the largest side. The shortest side is across from the smallest angle. So here's my shortest side, here's my smallest angle. So here's my little angle, here's the shortest side. And then this is just saying the converse. The largest angle, so angle B, is always going to be across from that largest side. The same thing is true from here. If this is my smallest angle, my smallest side, across from the smallest side is going to be the smallest angle and vice versa. So that means that the one that lies right in the middle is across from it, so A would be right across from it. Okay, triangle inequality. The sum of the lengths of any two sides of a triangle must be greater than the length of the third side, so that's the important part. The length of any side of the triangle must lie between the sum and difference of the lengths of the other two sides. So, here, the length of any side of a triangle must lie between the sum and difference. So let's talk about that. So the sum of 3 and 4 is 7, and the difference is 1. Does 5 lie between those two? Yes. Okay, so now that we've checked 3 and 4 with 5, let's try 4 and 5. So I add them up, I get 9, take the difference is 1, and in between that should be 3. Yep. Now let's check these two. Add them up, I get 8, in between better be 4, and then if I take the subtraction, it's 2. Yep, so this guy can be a triangle. Let's do the next one. So if I add up 3 and 4, I get 7. Okay, 7 should lie between that. 1, 7 between 7? Nope, we found our first mistake. that can't be a triangle. Why don't you go ahead and try the last one on your own? Okay, so if I add up 3 and 4, I get 7. If I take the difference, I get 1. So that means that 8 better be in the middle? Nope. All you need is one area where it doesn't work. So the only ones here that could be a triangle would be 3, 4, and 5. None of these could work.